So, welcome to the next point of the conductivity and resistance of the ionic solution. And in previous video we have restricted to specific resistance or resistivity. So today we are going a look on that specific resistance or resistivity. Now we know that R is directly proportional to length and A is inversely proportional to A, because length restrict the flow of electron, because as long as wire will be there, the more friction and therefore more resistance, but more area, more electron can go, so resistance will be less. So resistance depend on the length and area. To remove the proportionality, we have to put here the constant, the proportionality constant we have put here rho, and rho is known as the resistivity. Okay, so now here new word is coming, resistivity or specific resistance. It is one kind of nature of the metals or the substance. Okay, see, aluminum can pass more electron than that of the lead, though aluminum's resistivity is less and lead is having more resistivity. So that is, are you getting me? What is the idea behind to take the resistivity? It depends on the material. Okay, so that your first you have to keep in mind. Another one thing in resistivity, okay, it's a unit. Yes, yesterday in previous lecture we have talked about the unit of the resistivity, and unit of the resistivity was nothing but the ohm into meter, and these ohm into meters, how come that you know. Now the definition of the resistivity, and the definition of resistivity is very simple, and it is like this: the resistance per unit length of an in cross section area is called the resistivity or the specific resistance. So hope that you understand the definition of the resistivity. The resistance per unit length, resistance per unit length and per unit cross section area is called the resistivity or the specific resistance. And so after getting the some knowledge about the resistivity, we are entering in another thing, and that is the conductance. Dear students, as resistance is there, conductance is there. So what conductance says us, that we are going to look for. So conductance is nothing but the inverse of resistance. So inverse of resistance is called as conductance. What is conductance, dear students? Inverse of resistance is called as conductance. Okay, so here what is the inverse? So see the now writing, you can follow this, it is very simple. Okay, therefore G, the unit symbol of the conductance is G, and G is equals to 1 by R, resistance. And now we are performing here something. Okay, what is the value of actually R? So in previous topic we know that R is nothing but the rho into L by A. Okay, so this is the value. R is equals to rho into L by A. Hence, G is equals to inverse થઈ જશે બધું. આ કારણ કે R નીચે છે ને ડિનોમિનેટરમાં છે, તો બધું ઉલટું થઈ જશે કે 1 upon rho અને પેલું L by A છે તેના બદલે A by L થઈ જશે. So 1 upon rho multiply by A by L. Okay, the unit of the conductance is Siemens, SEIMENS. Slightly you have to check out. The conductance is denoted by G, its symbol is G, and unit is denoted by S. So what is the unit of the conductance? The unit of the conductance is G. Now what is conductance? Conductance is nothing but the inverse of resistance, means the allowed, what is allowed by the material to pass the electron, and that is known as the conductance. So hope that you understand this conductance. Now the topic is its symbol. So its symbol is G and its units is Siemens, and Siemens is also denoted by S. So that is your knowledge. Now conductance also can be measured into the mho inverse. See, what was the unit of the resistance? Ohm. તેનો ઇન્વર્સ લઈ લઈએ એટલે શું થઈ જશે? mho. જો MHO હવે શું બોલાશે? mho. એટલે OHM નું ઓમ છે એનું ઇન્વર્સ MHO. You are getting this? See. આ ઓમ આમ બોલાય છે ઓમ, તેનું ઇન્વર્સ means what? mho. That's I am taking here from inverse. આમ લખી દીધું. That is the also unit mho, and ohm is denoted by in this pattern. Okay, see આ પેટર્ન કેવું છે? ઓમની પેટર્ન આ રીતની છે, અહીંયાથી આમ ગયું છે, દેખાય છે? સો મોની પેટર્ન એનાથી ઉલટી ઇન્વર્સ લઈ લેવાનું છે. સો that is our idea about the conductance. Now conductance જે રીતે પેલામાં રેઝિસ્ટિવિટી આવે છે એ રીતે આની અંદર શું આવવું જોઈએ? Conductivity. Come on, let's see. Conductivity આવે છે કે નહીં આવે છે? That we are going to study. Yes. So now conductivity or specific conductance, that is the our new topic, and this will be more interesting. Okay. So we just derived it. G is equals to 1 upon rho into A by L, where 1 by rho is come. Now what is 1 by rho? So 1 by rho is known as the conductivity. જે રીતે conductance resistance નું inverse conductance થાય છે, એ રીતે resistivity નું inverse શું થવું જોઈએ? Conductivity થવું જોઈએ. So here resistivity નું inverse આપણે શું લઈ લીધું છે? Conductivity, and that will be the better performance here. So, and that is known as also specific conductance. Inverse of resistivity is called the conductivity because IUPAC has decided the word conductivity to use over the specific conductance. IUPAC શું કર્યું કે conductivity use કરો, specific conductance ના use કરો. So in place of now specific conductance, according to IUPAC, we will use the word conductivity, and its symbol is kappa. એનો symbol શું છે? kappa છે. And its unit is Siemens inverse or mho into meter inverse or ohm inverse meter inverse or Siemens into centimeter inverse. See here these two units are important. Kaya kaya? Siemens into meter inverse and Siemens into centimeter inverse, because these are the IUPAC. Sometimes to confuse you, these two units are also given. અહીંયા Siemens નો બીજો યુનિટ્સ આપણા પ્રીવિયસ એમાં ટોપિકમાં જોયું કે ઓમ છે, તો ઓમ ઇન્ટુ મીટર ઇન્વર્સ થઈ જશે, અને ઓમનું ઇન્વર્સ એટલે મોનું ઇન્વર્સ એટલે ઓમ ઇન્વર્સ એમ. તો આ રીતે આપણે આના વિશે વિચારીએ. પણ ધેટ પિંક કલર યુ હેવ ટુ રિમેમ્બર, વાયોલેટ કલર ઇઝ નોટ ટુ બી. સો ડોન્ટ યુ વરી. Okay, so hope that you understand the topic, and that's why now we are going to detail of the specific conductance or the conductivity, and how we can get that definitions and this all. So this will be the more interesting portion of the lesson, and here the conductivity is defined as if the 1 meter length of wire has unit cross section area also 1 meter. 1 meter length નો વાયર છે અને એનો ક્રોસ સેક્શન એરિયા કેટલો છે? 1 meter છે. Okay, then the conductance of the wire is called as specific conductance or conductivity. That is also 1 unit. એ પણ કેટલો હશે? 1 unit માં specific conductance or conductivity હશે. So this is the definition કે if the 1 meter length of the wire has unit cross section area 1 meter, then conductance of the wire is called as the specific conductance or conductivity. Now kappa is equals to 1 by rho, but rho ની વેલ્યુ તો આપણે કોના ઉપરથી? પેલા ઉપરથી શોધી શકીએ. See here, from where we can find out the value of rho? આના ઉપરથી કે rho is equals to L upon R. જો આ ઉપર જતું રહેશે, see here, આ rho ઉપર જતું રહેશે અને R નીચે આવી જશે, તો L upon R. So that value we can put there. આપણે ક્યાં મૂકી શકીએ? પેલા પ્લેસમાં મૂકી શકીએ. તો see here, that only done કે rho is equals to RA upon L. તો અહીંયા મૂકીએ તો કપ્પા is equals to શું થઈ જશે? L upon RA ઇન્વર્સ થઈ જશે કે કપ્પા રો ના નીચે RA આવશે અને ડિનોમિનેટરનો ડિનોમિનેટર ક્યાં જતો રહેશે? ઉપર જતો રહેશે. આર યુ ગેટિંગ ધીસ? અહીંયા આપણે શું મૂક્યું છે? આ રો ની વેલ્યુ છે, બરાબર? આ રો ની વેલ્યુની જગ્યા પર આપણે શું મૂકવાનું છે? R by RA by L. તો RA નીચે આવશે અને L ઉપર જતો રહેશે. So that is our idea. So L upon R. હવે એ બેને આપણે છૂટા લખ્યા છે. Here we have written that 1 upon R and 1 upon L. એ બીજાને આપણે એકબીજાથી છૂટા કરી નાખ્યા. That you can see here we have differentiate, but 1 upon R is nothing but the conductance. In previous topic we have studied. So here 1 upon R we can put G. So K is equals to G upon LA, and this LA is now more interesting. L by A is known as cell constant. L by A is known as cell constant, and it is denoted by G star, and that's why The kappa is equals to G into G star is our